Good morning, children. Today we take another application of the derivative, that is to find the maxima and the minima of f functions. Maxima and minima in the sense maximum value and minimum value of f functions. And before taking that you should have a definition of what is meant by the maximum value and what is meant by minimum value. The normal word meaning itself shows that the highest value of the function or the lowest value of the function. Highest value is called the maxima and the lowest value is called the minimum. But a mathematical definition is that suppose fx is a function defined on an interval, say I. Then we say that the function fx is having a maximum at a point C if f of c is greater than f of x for all x belongs to I. But this c belongs to c should be also in I. We say that the function fx is defined on I is said to have a maximum value at c belongs to I if f of c is greater than f of x for all x belongs to I. That is the definition of the maximum. Then we say c is the point where the function is having the highest value and f of c is the maximum value of the function. In a similar way, the minimum as c belongs to I is said to be the minimum value or c belongs to I is said to be a minimum of the function if f of c is less than f of x for all x belongs to I. C is called the point of minima and f of c is the minimum value of the function. That is the definition of maxima and minimum. Highest value and lowest value. Mathematically we define like that. Fx is a function, okay? Then c belongs to I and f of c is the maximum value of the function if f of c is greater than f of x for all x belongs to I. It is said to be a minimum value if f of c is less than fx for all x belongs to I. This is the definition of maxima and minima. Now let me draw three figures. I is equal to f of x is the function. Y is equal to f of x. Y is equal to this is figure 1 and this is figure 2 and this is figure 2. I have drawn the three figures and consider this one. In the figure you can see that this is the highest point. And the highest point is that what means if I say x is equal to c, then f of c will come to c. The highest point or highest value occur at x is equal to c. And f of c is the highest value. From the figure it is very clear. Now you can see that at this highest point, see, if I draw a tangent at this point, at the highest point, if I draw a tangent, you can see that the tangent is parallel to x-axis. So it means that at the highest point, the tangent is parallel to x-axis. That means slope of the tangent at the highest point is equal to slope of the x-axis because the tangent is parallel to x-axis. And we know that slope of tangent is dy by dx. That is why derivative is useful for finding out the maxima and the minima. So slope of the tangent is dy by dx and slope of x-axis, tangent is parallel to x-axis and slope of x-axis is equal to 0. So you can see that at the highest point dy by dx is equal to 0, or in another way we can say that f dash is equal to 0. Now come to this this one. From the figure it is seen that it is clear that this is the lowest point. Say x is equal to c, then f of c, this y value, this is the function's value at c. Now at the lowest point also you can see that when you drop a tangent at the lowest point, it is parallel to x-axis. So again the same thing comes, the f dash x is equal to 0. So it shows that at the highest point and at the lowest point, both point f dash x is 0. So that is one important result we get. In the maximum point or in the minimum point, f dash x is always 0. Now f dash x is equal to getting 0 does not give whether it is the highest point or whether it is the lowest point. It gives that it can be a lowest point or it can be a highest point also. Now we should have a specific which is the highest and which is the lowest. One condition is that at the highest point and the lowest point f dash x is 0. Now see the figure again. So we got the condition f dash x is equal to 0. Here also f dash x is equal to 0. Okay. Now you know that from the figure this is the highest point, and the left side of that point you can see that function is increasing, and right side of it function is decreasing. It is decreasing. If it is the highest point, it is clear that the left side of the turning point, we tell this point as a turning point when it reaches to high and then reduces. So at the left of that highest point f dash it is increasing function, and right side it is decreasing function. And you know that increasing function and decreasing functions we have already know that f dash is in the increasing interval f dash is positive, in the decreasing interval f dash is negative. Now the left side it is increasing. So here f dash x should be positive, and in the right side it is decreasing. So here f dash x should be negative. So now it is made clear that at the highest point f dash x is 0, left of it f dash x is positive, right of it f dash x is negative. Now come to the lowest point. In the lowest point you can see that it is decreasing. Left side it is decreasing. So here it is f dash x is less than 0. And the right side it is increasing. So here f dash x is greater than 0. So if it is the lowest point, left side of the turning point it is less than 0, and right side of the turning point it is greater than 0. So this will be the tool will be finding out for the maximum or the minimum point. So what is the condition? By seeing that you have to make this figure very clear. In the figure it is clear that if it is the highest point f dash x is positive is 0, and left side f dash x is positive, right side f dash x is negative. So to check the highest point, what we do is we find out f dash x and equate equal to 0. Thereby you get the turning point where it is the highest or where it is the lowest. And after getting that turning point, you take a left, say x is equal to 1 is the turning point. So take the value, find the value of the function at point 9, that is left side. You find out f dash 0.9, and same way take x is equal to 1.1 right side, f dash 1.1. So if f dash 0.9 it is the left side of the turning point. If left side if it is positive, this is positive, f dash is positive, right side it is negative, then we can call that point is the maximum point. So what is the working rule to be adopted is find out the f dash x and equate equal to 0, you get the turning point, and take that turning point and take left side of the turning point, find f dash. Right side of the turning point, find f dash. If left side positive and right side negative, then the turning point is a maximum. Now see here, the same way, if left side it is negative and right side it is positive, the turning point is a minimum. So this is what we use derivative for finding the maxima or minima. And one more thing just I would like to explain is, sometimes in the left side also f dash x is positive and the right side also f dash x is positive. That means f dash x does not change. Then we say that the point is a point of inflection. Is neither we can call as a point of maxima nor point of minima. So if the left and right side, if the value f dash x does not change, positive in the left side, right side also positive, negative in the left side, right side also negative, that means the sign does not change, both sides it gives the same, then we call that the point is a point of inflection. So I will just make it once again clear that how to find out the maxima and the minima of a function with the help of derivative. First you find out f dash x, then second step is find out, solve f dash x is equal to 0, get the turning point. After solving it, you get the value of x, they are called the turning point. And then find f dash left and f dash right of this turning point. F dash left and f dash right. If f dash left is positive and f dash right is negative, the point is a maxima. If f dash left is negative and f dash right it is positive, the turning point is minima. That is the way we find out. And if it does not change the sign, if it's left and right both, then it is called point of inflection. Now I have drawn a third figure also there. So when you discuss or use this tool for finding out the maxima and the minima, what happens here? This is a maxima, this is a minima, this is a maxima, and this is a minima. From the figure it is clear. So it shows that using that definition there is two maxima and two minima. So literally speaking, two maxima and two minima is not something correct way of saying. There are two maximum highest value and two minimum value. If I ask an example that who got the highest, say 459 is the highest mark, can we say that two children? If the two children got the same value, okay, we can say. But here they are different also. Height wise also they are different. So it is literally speaking, there is something wrong of saying that two maxima and two minima. To make it a little more clarity in that one, we use, this is the local maxima. In this particular locality, this is the highest, and in this locality, this is the highest. So local maxima and local minima. So this is another word which here is, it is same, almost same as the maxima and minima only. But we use the word local maxima and local minima to avoid that confusion. Sometimes people say that how can it be more than one maxima and more than one minima? To avoid that one, we use local maxima and local minima. So what are the methods for finding out the local maxima and local minima? It is find out f dash x, equal to 0, get the turning point, and then find f dash left of the turning point, f dash right of the turning point. If f dash left it is positive and f dash right it is negative, we call that turning point is a maxima. If f dash is negative, f dash left is negative, f dash right is positive, we call that turning point is a minimum point. And after getting the turning point, minimum point and maximum point, find out f of c. Suppose c is the maximum point, then f of c is the maximum value. If c is the minimum point, we say f of c is the minimum value. Don't be confused. Sometimes we use f of c, sometimes we use f dash c. You should be very clear about that one. F dash x is equal to 0, turning point. Then find out the left value and right value. F dash left value, that is very important. F dash left value and f dash right value at this turning point. And then find the maximum and minimum. Just one example I will give you. Say fx is equal to 2x cube minus 6x to find out what is the maxima or minima of this one. Now let me find out f dash x. The first step is f dash x, that is 6x squared minus 12x plus 12. Then f dash x is equal to 0 implies 6x squared minus 12x plus 12 is equal to 0. If I take, let me take this as 6 itself, let me conclude. Okay, 6x. So 6 when I take it outside. Okay, so this is 12x plus 6. Okay. So if I take 6 outside, then x squared minus 2x plus 1 is equal to, and it shows that 6 into x minus 1, this is x minus 1 also. It shows that x is equal to 1, you will get x is equal to 1. So the turning point is x is equal to 1. Now, to check whether it is a maximum point or minimum point, you should find out f dash left of 1, I will take 0.9. Okay. So 0.9, when I take 6 into 0.9 minus 1 whole square, you can see that is a square term, so it is always positive. And f dash 1.1, 6 into 1.1 minus 1, you can see that that is also positive. So it shows that the left side is positive, right side is also positive. That means it remains same. So we can neither we can call it as a maxima nor we can call it as a minima. We should call this point as point of inflection. So this is the way we can find out the maxima or minima or point of inflections. Okay, thank you.